Thank you for joining this lesson. We're going to discuss gas laws. In number 14, part A, state the pressure law. That should be state the pressure law of an ideal gas. The pressure law of an ideal gas. It states that for a fixed mass of a gas, the pressure is directly proportional to its absolute temperature provided the volume is kept constant. Provided the volume is kept constant, the pressure of an ideal gas is usually directly proportional to the absolute temperature. Explain how a gas exerts pressure. A gas exerts pressure due to what we call collisions. Therefore, the particles of the gas, or the molecules or the atoms of the gas, collide with the container exerting pressure. So the irregular collisions between the walls of the container and the gas molecules is what results to gas pressure. And remember, that's why we argue that now, in case the temperature is increased, we will have the collisions per unit time increasing and hence increasing pressure. That should be the kinetic explanation of the pressure law, whereby you increase the temperature, then collisions per unit time between the gas molecules and the walls of the container increases, hence resulting to an increase in pressure. You reduce temperature, the collisions decrease, and such leads to a decrease in the pressure exerted by the gas particles. In part C, the figure below shows a setup used to verify pressure law. We got a Bourdon gauge at this end. We have a stirrer, we have a thermometer, hot water. This is a glass flask. Then there is a dry air inside. Now we are taught to state the measurements that may be taken in the experiment. Something we may not fail to take is the pressure readings, or readings from the Bourdon gauge. Readings from the Bourdon gauge. This is simply the pressure, and because it is a pressure law which relates pressure and temperature, definitely the other reading is thermometer readings. Thermometer readings, which in simpler terms now means the temperature. So the temperature must be recorded. In part 2, explain how the measurements in one above will be used to verify. So what happens is that we record initial temperature and initial pressure of the gas. Then with time, or at regular intervals, record the new values of temperature with the corresponding values of pressure. You record a temperature value and you relate with the new value of pressure. Then after tabulating a few values, now plot pressure against temperature. Plot pressure against temperature. Then we note that a straight line shows that temperature and pressure are directly proportional. Directly proportional. Hence, pressure law verified. Hence, the pressure law is verified. Finally, a car tire is at a pressure of 5.0 times 10 to the power of 5 pascals at a temperature of 37 degrees Celsius. While it is running, the temperature rises to 75 degrees Celsius. What is the new tire pressure? What is the new tire pressure? Therefore, remember we have said that pressure is directly proportional to temperature. Therefore, pressure equals to a constant times temperature. So pressure out of temperature will give us a constant. That means even if we change the pressure to a different value, taking a different temperature, then they will give us the same constant. Therefore, T1, P1 equals to P2, T2. Yeah, that relation holds for the pressure law. Therefore, the first pressure is 5.0 times 10 power 5 Pascal out of the first temperature, which must be absolute temperature. So we add 273. We add 273 to 37 to give us 310 Kelvin equals to the new pressure out of the new temperature, which is 75 plus 273. This is equal to 348. 348. So to remain with P, we can multiply through by 348. So we need to take 348 times 5 multiplied by 10 power 5. Then we divide by 310. This is going to give us 5.661 times 10 power 5 Pascal. So that is the pressure value, which is new. Thank you for following. Subscribe and share.